820. Ready to go? So check this out. Remember I was installing it, not this 3D cell simulation. Uh, 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 uh. It's interesting. So by running step after step, the cells are moving, interaction is happening, tension is happening. Like, look at this. This is pretty cool. I still not quite fully understand how you can interact with this, if you can even interact with this. It definitely runs differently every single time. It's 10,000 flips energy. It looks so similar what I did for Nhive when I was running Nhive inside of containers, and I have steps and players. But it also same time looks a little bit ancient, like so. Trying to figure out what to do about it. I have many questions. Let's unpack them one by one. Mm, So number one, when you're saying in CC3D, you literally drop GRN into each cell and watch whether the network logic combination TF inputs. What is GRN? I probably need to read that paper. So link it to me and explain it in one paragraph, and then link it so I can read it in details. So then you're saying next paragraph, the sorting generation bioelectric pattern are demos or one paper away from them. That's I don't understand. Like what you mean they are one paper away from them? Who are one paper away from them? And actually, my most important question is CC3D actively used tool. It's open source and available, and it's actively used by biologists or by engineers everywhere. Is it actual? Is it latest and greatest in bioengineering, or there is a plenty other maybe commercial tools that can simulate? In other things, then you're saying like Go architecture on Google Cloud. Maybe I was thinking about slightly different. Obviously, run in the cloud, run batches, containers, all that. But I don't understand the sentence. But as of the 4.x rewrite, it's a conda package that can be called as objects. So what you're saying is CC3D currently going under refactoring. They're rewriting the whole engine, and soon I can, and it actually will help me out to start from. Or you saying there is no, or you saying there is a better, there is opportunity to write a better engine. That's what I don't understand a little bit. Your Go CLI generate parameter sweeps. Like, I don't want to just write a Go that generate bunch of parameters and then use that simulation. I'm very interested to write simulation itself, but I'm trying to figure out, is it needed for this world, or there is tools already available? So let's take a look into cell sort 2D. That's what we saw. Then bacterium, bacterium macrophage. Bacterium macrophage, I was fascinated on day 17 or 13 about it, how they eat it. So we definitely open up that now. Uh, File. First of all, I figure out how to install it. That's already cool. And I also know how to load the files. Maybe I know. Probably should not show that. Demos. Models. There's so many simulation already available. So how you write those simulations? That's also like, it's just parameters and then things start. That would be so cool. Oh, there's so much work. Bacterium macrophages. 2D. Steering. This one's saying that I need to turn off some. Whoa, that's so cool. Okay. So this is environment. It was macrophage here, and then something happened. We in a step have very little energy, very end at the step. Let's play it again. Yeah. And then it's dissipated, it died. Which one is macrophage and which one is... Okay. I don't know what is this. That's very interesting. Come on, green. Oh, almost fall apart. Where is like left, left, right, right? Like step by step. I want to go step by step. That's so interesting. I had very similar one. Very similar simulation where you can step by step replay what actually happened in simulation. You run thousands or millions of simulations, pick the most interesting one, and then step by step see what happening. Let me search GRN, Gene Regulatory Network. In a sense, I use a small dynamic system inside a cell where transcription factors regulate. That's what we were reading in the paper, right? This one. Yeah. Yeah. That's a paper we were reading. the where transfer factor regulates and downstream targets produce things like bistable switches, oscillators, or pattern forming logic. In CC3D context, especially in CC3D context, especially you write a GRN as the ODE system in anatomy. I don't know what that means. Explain me this. LibRoadrunner solves a separate copy of its inside every cell each Monte Carlo step. And GRN outputs TF concentration feedback into the cell CPM parameter. So it's kind of a driver, right? Like what I'm getting from the cell and what I'm pushing to the cell. That's the thing? Probably like a driver. Not a driver, the bridge connector. LibRoadrunner. So there is a function running inside of each cell, and I can determine which functions they are. So the pattern emerged from network logic plus cell level mechanism together, not from one of the cell. Did they done that? Two reading suggestions in order. Khalid Monk, Mini Lewis, 1996. Very well. Pattern information by pattern formation by laterin inhibition with feedback. A mathematical model of delta notch intercellular signaling. Where's the link? I'm not a bot. Accept all cookies. That I don't understand. Access to your organization. I don't have organization. Get rights and content. So I cannot see it basically, right? Yeah. PubMed. But there is no paper for like. That's what I still don't stand in science and how they all that paper. Is there multiple publication available for the papers and then they do citation to each other, or like can I read all public papers or some of them are private? You can have faulty access code foundational paper. View the abstract and access the articles through Science Direct. Wow, that's heavy. This is very heavy. Do I need to create account? Purchase PDF. Anyway, 2026. Maisel and Briscoe. This is this year paper. Gene regulator networks from correlative models to causal explanation. Oh, this is exactly what I was thinking about. Current state review that argues models must be inherently mechanistic. Models must be inherently mechanistic. Now I'm not sure. With structures grounded in cellular and evolutionary biology and molecular principles must be used to reduce the solution space for learning GRNs. This is directly in line with what you have been thinking through what David Peters update where the field is going. Open link. Accept all cookies. Abstract. Access options. Science is expensive. Like, I already found 10 websites that I need to subscribe. And again, access via your institution. Let's do a quick sidetrack because this is becoming more and more interesting. I need to understand the concept of that. So I'm a little bit in fog, meaning I'm not quite understand how it is established properly. So I'm very new to the science, and I understand that the whole point of become a scientist, not the whole point, but become a scientist unofficially means you write some paper, people review it. If they agree, then you are a scientist. And you read some paper, and you can review other paper. And that's how you kind of open source the science forward. So you making a claim, making experiments, show it how you done it, how you arrived to your conclusion, and if everyone agree, voila, you're a scientist, right? So in 2026, what's the trend and what's the whole situation? Because those papers are, is the number one question, is there like catalog of all scientific paper ever published somewhere? Can Google has see all of them and know everything? Number two, is LLMs know about them? Probably, or maybe not. Number three, so if there is not one unique catalog, those papers are getting published. So there is journals, right? Or publications. What are those publications? Is this like, are those organizations, non-profit organizations, or just unions or collaborations of people or commercial companies. And then what does it mean to be published in one of them? Can a paper be published in multiple publications or organizations, or it can be only pick one? And who is speaking? The organization looking for new paper, or papers getting submitted to organizations, and see who will publish it. Also regarding keep a track of it, I understand there is physical journal or magazine that I can order, right? But also I can, from my understanding, I can subscribe to many of those publications to read the papers. That's the whole idea. That's how they earn money. Another question of mine would be, in a lot of websites of those publications, they have a button access through the organization. And that's, I don't understand. Like, is there is that button, and is there a way for quote unquote scientists or students who can read those papers and use it and collaborate on it, probably not collaborate on it, but build on top of it or publish another paper on top of it? And they can do that for free if they accessing it from some kind of organization. And what that organization is that university, is that like research lab, or what kind of organization could it be? And most important question now, are they independent scientists? Like, I just trying to become one, I'm on my path to become one. What are my route? Should I join one of those organizations and to be part of it, to access those papers and read it, to collaborate, to find the mentors, to participate in discussions? Like, what are my strategy and plan? Give me short answers for all those questions. I don't need detailed explanation. Um, just so if I need go deeper in one of them, I will ask, but give me short, brief answers and give me the plan. Also, do a reality check and don't generate wishful thinking content. Ground your thoughts or plan based on reality and research. I'm talking to it like a human. Ground your thoughts. What are we talking about? That's definitely a side quest. Side quest. Oh, okay. So when we open this one up, we couldn't read it again because I need to access through some kind of nature.com. Open pay away from them. My bad phrasing. I mean, Levin's morphogenetics phenomena, cell sorting, generation, bioelectric pattern is already Okay. I mean, Levin, I either already shipped CC3D demos or there's published paper that's bridges Levin framework to concrete CC3D implementation. So Levin phenomena CC implementation is is at most one paper of distance, not you are one paper away from anything. Sorry for the milky sentence. So basically, if someone writes a paper, you can simulate it in CC3D, and it's a kind of cool way to demonstrate it. Yes, actively used. No, not the latest and greatest. That frame doesn't really apply here. HANA's landscape. Active. CC3D still publishes regularly. Paper from 2025 and 26 on its front page. Cortical tension and CPM endothermal immune cell interaction NIH funded workshop. Condas distributed its use for angiogenesis, bacterial colonies, cancer development, biology. So now I need to understand, like, but it's one of several. The CPM based niches has 3 main open source tools: CC3D, Morpheus. That's a good name. That's how you name your simulation. Morpheus. Artista. Oh my god, this is the startup I was part of. Teamwork of a slightly different UX and Artista, browser-based JavaScript re-implementation. So that's what I probably gonna do. It's definitely gonna be browser-based JavaScript, but JavaScript is just a player. It's not implementing the core. That's a very important. Like, you cannot write the core in JavaScript. You can only visualize. Outside CPM, the big alternative is PhysiCell. What is CPM? CPM based. So many questions. So many questions. Number one question here: what is CPM base niche means? What is CPM stands for? And number two, I definitely need a table comparison of CC3D, Morpheus, and Artisto. If I correctly understand, they rewrite the core in JavaScript for Artista. I actually want to use a JavaScript and web browser just to visualize and play simulation, but simulation itself happen in the backend in Go, or maybe later on in assembly. So it produces data, and then the player in a web browser play it. You can see it in 3D under any angle, but the data produced in the backend. And it's step-by-step player. So you can, at any step, you can stop, look from any angle, play it with different speed and so on. You can control it like YouTube player. Either frame by frame or just let it run. In a comparison table, definitely tell me the adoption, who is using what more, what it's adopt where, and then also tell me in different space. You said outside of CPM. Agent based with mechanic physics cell. Chased. Also find me a list of startups or company who actually taking it to commercial realm. So taking this simulation to commercial ROM, kind of a startup to provide the visualization and simulation to the biolab researchers or pharmaceutical researchers. Okay, I need to find. Calibration anchor, important. Mechanic, mechanistic multicellular simulation is a mature, slow-moving field. The latest and greatest in compound biology right now is on the other side of the building. Interesting. Foundation models. CS GPT, Geniform, EVO2. Perturbation prediction, AlphaFold 3. Those are about learning from data. CC3D is about encoding mechanism and running it forward. Okay. Different paradigm, different community, much smaller hype cycle. Both are valid, but if you're benchmarking against where the GPU clusters are venture money are going, CPM simulation is not it. For morphogenesis at tissue scale with explicit per cell biology through CC3 physics cell are still the canonical trial. There is no transformer that does this job, not even close. What's that mean? What does it mean there is no transformer that does this job? Which job and what is transformer? Not even close. And regarding to models that learn like AlphaFold and so on, those are predicting, yes. But that's interesting. You're saying simulation is kind of playing the data, but it also producing synthetic data, right? Simulation produce synthetic data, and then if we can verify it, that's the whole point. To produce data in a lab, it takes millions of dollars and a lot of time. Produce synthetic data is way more cheaper. So those models, foundational models, can learn from synthetic data, but then it might be not biologically baked, right? I don't know. I think we went way too deep. Way too deep. Linked, let me handle this together. Point 6. Regarding your question 6, I think misjudge what you are after. I was suggesting using it as the engine wrap it in Go. Your Go program generates parameter combination span and yeah. A post process useful but unambitious. You are telling me that's not the interesting part. Good. Let me pivot. If you want to build the engine itself, here's the harness map. The core algorithm is small. A CPM is a 2D, 3D integer lattice where each cell occupies a connected. Yeah, I got it. Go is generally but partial. Inner MCP loop wants SMA GPU for pixel flip. Yeah, I'm not flipping the pixels. The interesting frontier question, where the building new engine actually produce novelty, not just a re-implementation. That's a good question. GPU for CPM with a clean API, most Existing GPU work is research code add-ons to CC, not first class. Okay. Differentiable CPM Hamil- Hamilton terms as outer drift friendly function gradient through the stochastic MC dynamics. This would let you feed CPM parameters to imagine data instead of hand tuning. Nobody has nailed this yet. Yeah, I don't know. Foundation model coupling. Replace the hand-written GRN ODEs with predictions from the GPT GM form class model. I was saying, yeah, the CPM becomes the spatial engine. The foundation model becomes the pure cell biology open ground. Interesting. Cloud native architecture. Most CPM tools assume the step of a CPM engine designed for ephemeral cloud workers, with checkpoints resumed to object storage would be generally new. Mechanism before deciding spent a day reading several posts GL source much faster than CZ. It's small enough to read end to end and will give you concrete sense of what an implementation actually is. Okay. Fee for the rewrites. Okay, done. Not ongoing. Oh, it's done. Not ongoing. In 2020, compute self development focus shifted to improving flexibility and interior interoperability, and CC3D become a Conda package. This change allowed calling simulation as objects, script master parameter, yeah, got it, stable. That's the rewrite I was referring to. This is current state, not a moving target, so the baseline starts from stable and the version tag treadmill won't bite you. The C++ core is much older and has accumulated complexity, which is part of why Celebrity is a useful reference. CPM retains partial information like geometry. Okay, explain me the context of software engineering. Sure. Talk the SE analogy literally is combination pipeline. Compilation pipeline. Okay. ODE system equals the program. ODE, ordinary differential equation, is a rule of the form the rate of change of x equals f current state. dA dt equal k minus a means a decays proportional to itself. A system. This is terrible explanation. A system of ideas is just several of those coupled together. One variable's rate depends on the other. Mechanically, it's a state machine which continues state. At every infinitesimal dt, you compute the divergent vector from the current state and apply it. An ODE solver Ranji, Kutas, different numerical models is a runtime that integrates the so forward in time. So solving a system is just running the program. The whole thing is roughly equivalent to a game loop where state evolves continuously instead of the discrete ticks. That's a big rain. The whole thing is roughly equivalent to a game loop where state evolves continuously instead of discrete ticks. I'm not sure about that. Autonomy, the source language, is DSL for writing biomechanic networks in human readable text. A toy example. A to B K converts to B at rate K. B converts to C at rate. The pipeline maps cleanly to anything you have written before. High level DSL, antimony, compiler, machine readable, runtime interpreter, lib roadrunner v1. Numerical identity. You write antimony. It gets translated to SMBL, the standardized XML interchange format. Every system below tool reads, writes is a VM that parse SMBL state, reads when the solver evaluates the state going forward. Why this matter for CC3D, especially in simulation? Each cell on the lattice gets its own instance of a SBML model running inside it. It owns state vectors for ABC. So MCU might have 500 cells in 500 independent libroad runners, instance ticking in parallel, each with its own concentration evolving. Okay, the CPM step is the outer loop. Cell moves this wide random. Okay. Do you deep research in anyone done this already? Yes, extensively. The parent done what already? Describe is a novel direction. This is the internal work backend. It's not just done, it's the founding use case of similar integration. Okay, the shipped demo delta notch lateral inhabitant, the connector and build the Python layer user found in paper integration dynamic using compute and by multiple. Okay, so in 2012 they was the first published end-to-end demonstration CPM tissue simulation where each cell run assemble define concept publish application sampling a scan of what's been built using this exact pattern. Okay. And it's not just in doing the same pattern exists in physical set. Lib Roadrunner is used as a core as a SBML handling component in the model software designed by Tellurium, Runbelisme, MassPies, and computers. Where the real frontier actually is. This is the part worth dwelling on because it answers the implicit follow-up. Okay, so what's left to do? Yes. The architecture is matter. The content is the limitation factor. Especially, yeah, so rewriting architecture. GRN scale. Virtually all published season paper use small networks, typically 5 to 30 species, often a single signaling pathway. Nobody has plugged in a Davidson-Peters scale and Domers and GRN. Support must boss for exactly that, but I haven't seen any more write in full Davidson via mass boss and the published. That's a very interesting. That's what I was clicked first, mass boss. Foundation model coupling. Nobody has replaced the handwritten intercellular ODE with the foundational model prediction. Producing per cell perturbation responses on the fly. This is generally open ground. The interface points exist per cell state vector that update each MCS. It's just that nobody has done the engineering. Cloud native parameter sweeps at scale. Tego, COVID paper, do parameter sweep but on traditional differential coupling. Nobody has made the SBML coupling after differential so you can feed to data end to end. Hard problem. Stochastic MC inside, but open. Levin style cognitive morphological decision making at the general scale. Levin's framework talks about morphogenetics competence in agentic terms. There is no published model that explicitly instruments cell make decision based on a generally driven model on the environment. This breach is generally unbuilt. Natarfa, the engineering pattern you describe has been built, validated, and shipped for 13 plus years. What has been done in connecting that engineering pattern to the scale generator model? You'd want from Davidson Peter side of computational biology, see agentic cognitive framing that slant works. Each of those are real open direction if you're looking for what should be built already. Okay, we finally get to the CPM. CPM base niche mean cellular POTS model, also called the Glaser Granel Hogeweg GGH model. It's a specific algorithm. Cells are represented as connected sets of pixels on a lattice that share an ID. Oh, I see. CPM. An energy function, Hamilton defines the cost of any configuration, and a Monte Carlo pixel flip evolves the system over time. Got it. So that's a very interesting thing. We go to CPM, or like I want to go to vectors, not the pixels. Like why pixels? Pixels are static, like vectors. Pixels, it's a result on a end device. Vectors is the raw data. The subfields of molecular simulation tools that use CPM as the core engine. So when I said CC3D, Morpheus and R are in the CPM base niche, I mean they all share the same algorithm foundation. There are three different implementations of the same underlying math. Outside the niche are tools that speak a different algorithm. Physical cell of lattice agent base with mechanical forces. Chester, vertex model. I think Chester would be it. Pure JavaScript, out. Engine custom GNU, Morpheus, see, nice. And see, they did same CPM, yeah. Wait, runs, desktop browser, any known style. None built in your right JavaScript. SMM via Libra Max Boss for Boolean. Boss full 3D. Intercellular networks. SBML via Leap Roadrunner. Max Boss for Boolean. Import supports over 80% of HTML L3 v2 and package comes validate also native ODE SDD Morpheus. Reaction diffusion. Yes, multiple solvers. Yes, adaptive solvers basic. Cell logic. Adherence, chemotaxis, mitosis, custom steppable. Same GNU defined. Using a built-in player VTK with a built-in viewer, renders online in browser canvas. parameter sweeps, headless cluster, best for heavy multi-scale plus SML cluster runs, declarative modeling, teaching, fast prototyping. Morphle pitches declarative angle construct models by describing them in a GU instead of programming code. With more ML language for each sharing, Astro is JavaScript design code and has no major performance disadvantage compared to C framework. Its primary is sharing technology, teaching tools. Okay, your architecture vision, this already exists and you should look it before building. You describe backend produce simulation that a browser places backend timelines, describe 3D camera show frame by frame, speed control. This is almost exactly the simulation viewer from the Alien Institute of Cell Science project paper. Project paper, it has a paper simulation viewer to 2022. What is 2026? 4 years ago, GitHub repository. Oh, nice. Simulation exports them. It's already integrated with both CPM-based tools and other physical cell file export simulation options that converts physical cell output and the convert simulation so the backend and any linear trajectory file web viewer pipelines dominate explicit in space. Implication of what you are building in Go. The simulation backend in Go is generally new part. And Institute didn't write the simulation. They wrote the standard trajectory from plus viewer. You could ship a Go by CPM or other engines that target the simularium target from post. Alternate ship your own viewer differently. Adaptation. Who is actually use this? Honest picture from publication panel Conda downloads GitHub activity and the border the strongest in development biology morphogenesis. Strong in European system biology, strong in sharing demos, beyond the niche adaptation of larger cliff US community special by raw adoption, I guess, non-published down the metric. Outside CPM, the engine-based landscape, model type, scale, lines, BSD, open. Startups and commercial activity. Hans landscape here is uncomfortable. There is no major commercial player whose core product is multicellular tissue simulation CPM or agent-based mechanism sense. This space is academic. The commercial money in computational biology is going elsewhere. Yep, good. What does exist? Organized by category. Cell level digital twins. Deep Life use Omic data creates digital twins of cell in silico, moving single cell analysis from a vitro to silico. This is good. Has profound application for drug development. Oh, okay.